Go and open your book to page 509. So today's lesson is just like the previous one. Okay, you need to look for the terms, but this is a different technique. But before we get into a technique, first let's go into some of the terminology. Okay, so on the bottom of page 509, you're going to have a notation like R. Okay, this is called R factorial. So R factorial means it's a multiplication. So for example, if you have 4 factorial, this is equal to 4 times 3 times 2 times 1. Okay, so this will equal to 24 and so forth. So if it's like 7 factorial, this would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, now you don't have to multiply out manually because on the calculator, if you look over here, there is a factorial button right over here. See this one over here? Okay, so you can use that. So to enter, you just, for example, if you're looking for 7 factorial, don't waste your time like writing it out. You can just use calculator. So you enter 7, and you push this factorial button, so go second, and this button, and it will give you the number. Okay, so it would be 5040. So this is called a factorial. Okay, now you need to make sure you remember some of the basic factorial. So 0 factorial by definition is 1. So 1 factorial equal to 1. 2 factorial equal to 2 times 1, so equal to 2. And 3 factorial equal to 3 times 2 times 1 equal to 6, and so forth and so forth. Okay? So that's the factorial. Again, you use your calculator. So like 3 factorial, you can just go enter 3, second function, and it give you 6. Okay? So that's a factorial. And now you're going to use a factorial to do the problems. Okay. Now, go to page 510. So page 510, you have this binomial theorem in the red box. So if you look at this box, okay, so this is a very long formula. Okay, so you need to memorize it and use it. Okay, and it sounds very complicated, but actually it's super simple. Okay, that's why you have a teacher to explain to you how it works. It's super simple. Okay, so this is how it's going to work. So let's say if you have this example. Okay, let's say you got 2x minus y to the 5th power. Okay. So if you're going to, so you are using the Pascal triangle, right? You can do that, right? Or you can use the binomial theorem. Okay, you can use either technique. Now each one has advantage and disadvantage. Okay, Pascal triangle works really well, very fast if you have a low exponent. If the exponent is kind of fairly low, maybe up to about 6. Okay, you can use Pascal triangle. It's fast. Okay, but if it get higher, you want to use binomial theorem. Expansion is much quicker. So it depends on the exponent. Or binomial theorem, you can use it to get any term of any exponent directly without having to making the Pascal triangle. Okay? So again, remember, so same technique. Okay? So the difference is that you can use binomial theorem or Pascal triangle to get the coefficients. The other parts are the same. So if there's a 5th power, you're going to get 6 terms, right? So you do that. So 1, 2, 3. You know, I'm going to turn sideways. Okay, let's start this over again. So again, 5th exponent. So it's going to be 6 terms. So that's 1, 2, 3, 4, 5, 6, right? So again, every term you need to have 3 parentheses. Okay, and again, just like before, when you're using the Pascal triangle, right? So you're going to get 2x to the 5, 2x to the 4, 2x to the 3, 2x to the 2, 2x to the 1, 2x to the 0, And then the second part would be minus y to the 0, negative y to the 1, negative y to the 2, negative y to the 3, negative y to the 4, negative y to the 5. Okay, so it's the same. Okay, now the binomial theorem is saying this. Okay, to get the first one, okay, all you have to do is the total. See the 5? You're going to get 5 factorial on the top, and you see these two numbers over here. That's what you're going to get on the bottom. So you're going to get 5 factorial, 0 factorial. Okay, over here you're going to get 5 factorial over 4 factorial, 1 factorial. Over here you're going to get 5 factorial over 3 factorial, 2 factorial. Okay, over here you're going to get 5 factorial over 2 factorial, 3 factorial. Over here you're going to get 5 factorial, 1 factorial, 4 factorial. See that? And over here you're going to get 5 factorial, 0 factorial, 5 factorial. That's what binomial theorem says. Again, it seems very complicated, but if you understand, it's super easy. Okay? So again, the total goes on the top, and this two number goes on the bottom. Your next step is evaluate each one. Okay? Evaluate each parentheses. So 5 factorial and 5 factorial cancels out, right? And 0 factorial is 1, so this will give you 1. And this one will give you 32 x to the 5. And this one, anything to the 0 power is 1. Right? Remember to evaluate each parentheses before you multiply out. Okay? Now this 5 factorial divided by 4 factorial, right? So this will give you a 5. Right? Because 5 factorial is 5 times 4 times 3 times 2 times 1, right? And 4 factorial is 4, 3, 2, 1. So all the 4, 3, 2, 1 we cancel out, so you end up with 5. Right? Again, this one, 5 factorial over 4 factorial equal to 5, 4, 3, 2, 1, right? And 4 factorial is 4, 3, 2, 1. See that? So all this got cancelled out. That's how I get the 5. Or just use calculator. Okay? Now 2x to the 4th power will give you 16x to the 4. Negative y to 1 power is negative y. Okay, this one over here, again you can use your calculator. So 5, so it's 10. And this will give you 8x to the 3. And this one will give you y squared. Okay, and this one will give you 10, 4x squared, negative y to the 3. Okay, this one over here plus 5, 2x, y to the 4. Okay, plus this one would be 1, 1, negative y to the 5. Okay, and after you, so make sure you remember to do this step. This is very important step. Okay, so make sure you evaluate each parentheses, and then after that you work it out. So this will give you 32x to the 5 minus 80x to the 4 y. This one will give you plus 80x to the 3 y squared. This one will give you minus 40x squared y to the 3. This one will give you plus 10x y to the 4 minus y to the 5. And that's how you extend that. Okay. Okay, so now let's go over some. So this is when you have to do the whole thing. Okay. So let's say if they only ask you for particular terms. So let's go to page 511, and let's do number 18. So number 18, you're looking for the term containing b to the 11th power in a minus b to the 15th power. Oh, one more thing. Notice over here, you have to figure out which term over here. So notice T1 is this to the 0 power. T2 is when this to 1 power. T3 is when this to the 2nd power. This is T4. This is when the last part to the 3 power. T5 is when this is the 4th power. T6 is this when this 5th power. So notice that the n and the exponent are off by 1. Okay, so just remember that. If you don't remember, just do the first term and you can see a relationship. Okay, so in case if they ask you to find like a T5 or whatever T, then you can figure out this part over here. Okay, so again, notice the relationship between the n and the exponent. Okay, so that's very important. Okay, now let's get back to 18. So you're looking for the term has b to the 11th power. So remember, every term has 3 parentheses, right? So this one will have an a to something. This would be b to the something, right? So again, the a goes over here, right? Every parenthesis has that. Okay. Now, you're looking for 11th power, so that means you need to get 11 over here, right? Now, if this is 11, to make up to 15, you need to have a 4 over here, right? So once you get these two numbers, the coefficient would be 15 factorial over 4 factorial, 11 factorial. So now you get your calculator, work out each part. So you have 15 factorial divided by 4 factorial. Now you have to divide. Everything on the bottom you have to divide. So you have to divide 11 factorial equal. Okay, so remember to push equal. So it would be 1365. And this would be a to the 4, negative b to the 11. And you work it out. So it would be negative 1365, a to the 4, b to the 11. Okay, so that's how you find out the term with b to the 11. Okay, let's do number 20. You're looking for the 14th term, so you're looking for t14. Okay, so you have s plus t to the 14th power. So again, every term has 3 parts. So you have s, you have the t, and you have the coefficient part. Okay, now if it's t14, this would be 13. Okay, right? Now this t and this t are different, right? This is term, and this is the variable t. But if this t14, your exponent must be 13. Okay, again, remember from what we see over here, right? The n is always 1 greater than the exponent, right? So see, this is 6 and 5, right? So this is 14, this would be 13. Okay, so once you figure out this is 13, this would be 1, right? Because you need to have 1 and 13 to make 14. And then this would be 14 factorial over 1 factorial, 13 factorial. Now, this one you don't even need to use calculator, right? Because everything up to 13 will cancel out. So only thing left would be 14, right? So this would be 14 already. And this would be s, this would be t to the 13. Again, make sure you do this step. Don't get lazy. Okay, it only takes a few seconds to do this. Then you multiply out. Okay, and that's your answer. Okay, let's go to number 22. Okay, you're looking for the term containing x squared. So you have 2x minus y to the 7th power. So you're looking for the term that's an x squared. So again, every term has 3 parts. So you're going to have 2x minus y. Okay. So now in order to get x squared, that means you need to have a square over here, right? So if this is 2, then you need to have a 5, right? 2 and 5 make it a 7, right? So you have to kind of use that. So you have to think it through step by step. So this will give you 7 factorial over 2 factorial, 5 factorial. Okay. So again, you can use your calculator, work it out. So 7 factorial divided by 2 factorial divided by, remember everything on the denominator you have to divide, right? 5 factorial equal 21. And this one you work it out, you get 4x squared. This one you work it out, get negative y to the 5. And now you work it out, so you get negative 84 x squared y. Okay. Okay, let's go to number 24. So you're looking for the term that contains b to the 12th power. So you got a plus 3b to the 3 to the 5. Okay. So you're looking for the term with b to the 12th power. Okay. So again, every term has 3 parts.
The y has to have a 5 on the previous paragraph. The answer has to be y.
Oh, okay, thanks. Sorry. Yeah, need to have y to the 5 because of that. Okay. Okay, next part. Okay, again, every term has 3 parts. So you need to have an a, you need to have 3b to the q, right? So now you have to figure out the exponent. So in order to get b to the 12th power, you need to have a 4th power over here, right? Because b to the 3 to the 4th power will give you b to the 12. So from this part, you figure out the exponent 4. So once you figure out exponent 4 over here, you need to have 1 over here, right? So that means you got 1 and 4. So you're going to get 5 factorial over 1 factorial, 4 factorial. So work out each parenthesis. So this would be a 5. This would be a a. This would be 3 to the 4th power. So it would be 81. Right? 3 to the 4th power is 81. And this would be b to the 12th power. So now you work it out. you get 405 A, B to the 12. And that's it. Okay? Okay, so let's go and do some practice. Okay, so B, just do the B part. Don't do the A part for 13 and 15. Okay?